I welcome on today's tutorial. Before we start to write queries in MySQL, I would like make we understand some of the core concepts in relational databases. And some of these core concepts, they centered around database tables, keys, and the common data types we did. Just as we don't already do for our previous tutorial for inside Microsoft Excel for data analytics. If we watch that tutorial, we go remember say we get tables, we get rows and columns. So make we see as tables they be for inside SQL. The tables they similar, and we they always get the same rows and columns. So now example of a table be this, now student table be this, and this student table contains some attributes. That is the student's ID number, the student's name, and the subject. So as we see them, we have columns and rows. Our columns contain single attribute while our rows contain individual entry. So make we see example. Now our rows be this. If you look at very well, now each individual entry they contain in the rows. For example, the person with student ID number 1, in name na a maker and in subject na agriculture. So now one individual entry be that. Another individual entry now the person will get student ID number 2, and the name na Aminat, the subject na English, and so on like that. So our rows they usually contain individual entry, while our columns, as we don't talk, they contain a single attribute. So as we don't talk before, example of these attributes now student ID, student name, and subject. So for example, the person with student ID number 2, the subject na English. So now under the subject attribute English day. So these columns, then they define certain aspects of the table. The student name column, they highlight the names of the student. The student ID column, they highlight the number of the student, the unique number of the student, and the subject, they highlight the subject with them they offer. So now our database tables go be this. So today different from which we don't already learn for Microsoft Excel. So another thing where I want show us for this table now the primary key. Anytime we will create table for relational database, we always create one column we go be the primary key. Now this primary key, what thing they do? Primary key are like attributes where they uniquely define a row in a database. In this case, now student ID. And what in the student ID they do for this table, which function they perform for this table? We they use them identify a specific row for inside the database. So for instance, if we want to identify the information with the row 5, we know say the student name now Ibrahim and the subject where they offer now statistics. So anytime we will get table for inside database, it is very important make we define the primary key. This primary key they usually they unique. And inside this student table, for example, not two students fit get the same student ID. Students fit get the same name. 2 people fit they bear Emeka. 3 people fit they bear Ayo. In fact, 2 people fit they offer subject. For example, if you look the student ID 2 and student ID 4, they offer the same subject, English. So but no 2 rows fit get the same primary key. And this one means say our primary key is unique to each row. And our primary key, if it be anything, if it be numbers, if it be text, but the most important thing be say it must uniquely identify the specific row. Make we see another example. Now another table be this. Now a user table be this. So that it would be easy for us to identify the primary key and the other columns. I don't underline the primary key and I don't color the background red. So our primary key here now the email. 2 people will get the same password. 2 people will create their account on the same date, and 2 people will get the same account type, but 2 people no fit get the same email. And so our email here now the primary key. So the primary key they uniquely define these particular rows. So if you don't see Ayo at school.com, you go know say now your own unique account be this. So the primary keys they very important, because now we go take uniquely identify the row. Now we go take define each row. Okay, make we consider this table. Now another table be this, and now employee table be this. In this employee table, we have the employee ID number, we have the first name of the employee, last name, the birth date, the sex, and the salary where the employee they collect. Now, if you notice this very well, you see say we don't have primary key. And our primary key, they uniquely identify each of these employees. The person will get employee ID 001, na Ade Oladapo. The person will get employee ID 004, na Banks Eyitemi. If you look this primary key very well, wetin we dey use am do for inside this table na say they identify each row and they do am uniquely. But if you look am, we no fit really use this employee ID for anything in the real world. For example, if you dey work in a company and your employee number for the company na maybe 101. 101 no really get any use case in the real world. So now this kind of keys we dey call surrogate key. They be primary keys, but we refer to them as surrogate key because they don't get any real use case in the real world. They don't get any mapping for the real world. Make we look another example. Now another employee table be this, and it is very similar to our first table, but the only difference now say this employee table now the NIN we they use as the primary key, the employee NIN. NIN stands for National Identification Number. We they use them in Nigeria as a unique number where they identify Nigerian citizens. If you look this employee NIN, if you compare to our table where they up here, employee ID, you go see say NIN they useful in the real world. It gets real use case in the real world. For example, it gets some things where you know fit open or where you know fit do if you don't get NIN. If it be maybe bank account or even international passport. So our NIN gets real use case in the world, and our primary key be this. So now this kind of key we they call natural key because say it gets real use case for the real world. So any primary key we no get any use case for the real world, we call them surrogate key because they don't get any mapping or use in real life. While natural key, it get purpose in the real world. So make we move on. Make we consider another table. Now if you look this table very well, it is similar to our previous table, but we don't make one addition. And that one are the branch ID. So now our branch ID, now be this. Now our primary key be this. Our other columns, first name, last name, birth date, sex, salary, and then our new column, which is the branch ID. Now you get another thing where we call foreign key. And waiting be foreign key. Foreign key are like an attribute where we say we fit store on a database table. We fit link us to another database table. For example, this branch ID now, if you link us to another table where we say we go fit take identify that table with this foreign key. Waiting foreign keys they do basically. Now say then they store the primary key of a row in another database table. In simple terms, our foreign key here now the primary key of another table. So our table be this, now our primary key be this, and here now our foreign key. So make we observe another table. Now if you look this table very well, we get our branch ID, our branch name, and our manager ID. Now as we don't explain before, if you look at this branch ID here, now it be the foreign key for this table. But if you look at here, now it be the primary key of this table. So this table self get your own primary key, you get your own foreign key. So now this table they related to this table. Now why would they call all these things relational database? Because they get relationship. For example, if you just say the employee ID 001, who is Ade Oladapo, born in this particular year, male, and earns this much salary, if they work at branch ID number 1, it means say they work at Lagos. This one, maybe this person with the employee ID 003, or Dizzy Justina with all these other details, if they work at branch ID number 3, that one means say they work in Jos. And now even this one, it get in primary key, it even gets in own foreign key. Where we say you link them to another table. So the person where they manage the Lagos branch, now with the manager ID 001, and now the employee ID with this. So 001 now Ade Oladapo. So it means say Ade Oladapo they work for the Lagos branch, and now they manage the Lagos branch. Here the manager ID of Jos now 002. So now Yaya Suleiman they manage the Jos branch, while the Enugu branch the manager ID now with the employee. So the manager ID of Enugu branch now 004. If you look 004 here now, banks me. So now she they manage the Enugu branch. So now how foreign keys fit describe the relationship between two or more database tables be this. I'll make we observe another table. Our employee table be this, and we don't make some modifications. We have our primary key, and then our other columns where they describe these attributes. And then if you notice now, we get two foreign keys. I don't color the background green so that it go dey easy for us to understand. So I color this one red to show say now the primary key, and this one's blue to show say now just column names. Now our foreign keys be this, but we get two foreign keys inside one table. So now it be say one table fit get more than one foreign key. And wetin our foreign keys they do, we don't explain them before. Say our foreign keys they describe the relationship between database tables. So this branch ID now they describe the relationship between this table and another table, maybe the branch table, and this supervisor ID they describe the relationship between the employee table and the supervisor table. So now the branch ID be this. So we don't show the relationship between our employee table and our branch table before. So we know say those we get branch ID 3, then they work in the Jos branch. So for example, Odize Justina, because say she did branch ID 3, so we know say she did work for the Jos branch. So now make we look at the supervisor ID column, this foreign key. The supervisor ID for employee ID Oladapo with employee ID 001. No. So that one means say this person no get supervisor. But now maybe we can look at the employee with ID 002, Yaya Sulaiman. The supervisor ID now 001. So that one now be say now supervisor be this. This person too, or this is Justina. The supervisor ID now 001. So it means say Ade Oladapo now these people supervisor, both Yaya and Odize. While these other two they have their supervisor ID as 002 and 002. So it means that their own supervisor now Yahaya Sulaiman. So and then from here we know say now this 001 now they manage the Lagos branch, and now employee with employee ID 002 now they manage the Jos branch. So now we will describe relationship between two tables using primary keys and foreign keys with this. Okay, so make we observe another table. Now our employee table be this. We don't see this one. And now our branch table be this. Now we don't add another new table, which is the supplier table. Now if you look this employee table, you go see we get one primary key, although here we get two foreign keys. And don't forget, we don't talk say table we get two foreign keys. In our branch table we get one primary key and one foreign key. But if you notice our supplier table here, we get two primary keys, our branch ID and our supplier name. So when we see two primary keys, that one we say then be composite key or composite key. So a composite key they refer to more than one primary key. And if you look this composite key, then they refer to specific details. So why would they use composite key? We they use them when a primary key does not uniquely identify a row. So for instance, make we take this branch ID as an example. It doesn't uniquely identify this row because we get another branch ID with ID 2. Here we get 1, 2, 3, 4. 4 branch ID here where they describe this supplier name and supplier type. So they don't uniquely identify this row. Branch ID 3 does not uniquely identify this row because you get other rows we get branch ID 3. But when you combine them with the other primary key, which is the supplier name, and it becomes a composite key, then you can now uniquely identify each row. So for example, we know say branch ID 2, which is the Enugu branch, they get flour supply from flour mills. Then here we know say branch ID 2, which is still the Enugu branch, they get supply of beverages from Nestle Nigeria PLC. Honeywell Foods they supply branch ID 3 wheat. UAC Foods they supply branch ID 3 cooking oil. Dancer Food they supply juice to branch ID 3. If you look here very well, you'll see say flour mill appear 2 times. But this flour mill they supply the branch ID 2, which is the Enugu branch, while flour mill still they supply branch ID 3, which is the Jos branch. So now only when these two columns they together to form a composite key, now only then we fit uniquely identify each row. So now wetin composite key they do be this. So make we look at the last example. So now the employee table, the branch table, and now we get client table. We have a client ID, client name, and branch ID. So for example, Foodco gets client ID 100, ShopRite you get client ID 101, and then the branch ID. So you know say the branch ID they relate with this particular table. So you gonna say this one are Foodco for branch ID number 2, which is Enugu. This one are ShopRite for branch ID number 2, which is also Enugu. So and so on like that. Make we consider another table. So now if you look at this table too, we get 2 primary keys, which is a composite key. This table they related to this table because you know we have our employee ID. It is related to this table too because we have our client ID. So make we see as them take relate. So employee with ID 003, which is Odeze Justina, they work with client ID 100, which is Foodco, with a total sales of 27 million. Employee with ID 002, which is Yahaya Sulaiman, with client ID 101. 101 here is ShopRite, and he has made a sales of 45 million. So we see as these tables they related. So I just want to make we familiarize ourselves with this table because we're going to see this kind of similar relationship between tables for inside MySQL. So and finally, make we just go see some common data types. So as we don't talk in our introductory lesson, we get several SQL data types. But now some of the common ones I just want to quickly explain before we begin to write our queries. So in SQL, the columns of a table, then they define to store a specific kind of value. That value if it be numbers, if it be dates, if it be text. Now those values where we store, we call them data types. SQL gets several types of data types. We don't mention some of them for the introductory course. But SQL gets over 30 types of data types to choose from. Once you don't understand data type, you go know say no be complicated thing. You go also understand why we need data types and why many varieties dey. Make we take example. Maybe you want collect information about a person. Maybe you want collect information to describe a person. Some of the information where you go collect fit be name, birthday, weight, and maybe number of children, or maybe marital status, and so on. So those names, for example, those names we collect, we go store them as text. Those birth dates, we go store them as date. Those weights, we go store them as decimal values. The number of children, we fit store them as integers, and so on. So each of these categories of values where we store, now wetin we dey call data type. So make we look at some of the commonly used ones. So the int data type, int stands for integer. The integer data type, they store whole numbers. Whole numbers no include decimal places since SQL Server they use number of computer words to represent an integer. Another data type now the decimal data type. The decimal data type they store decimal numbers. So for example, maybe 29.0 or 365.365. If you look very well, you'll see I put XX in front here. It means if you want enter decimal format, you go enter 2 values. And now the first value go show the total number of digits where you want store, while the second value go show the total number of digits wey you wan store after the decimal point. As we continue for the tutorial, we go really understand some of the use cases of these data types. Another data type wey be say e dey commonly used na varchar. Varchar means variable character, and this one na text we dey use am store. I don put XCSF because e dey allow us choose the length of the text wey we wan store. So we go understand that one later as we begin to enter and manipulate data for inside MySQL. Then the bit data type, this one dey store boolean or yes or no values. E get sometimes wey be say you just need to store if something dey true or false. You fit use one signify say na true, or you fit use 0 signify say na false, or you fit just put null maybe if you no get any value. So they use the bit data type to store this kind of values. Then we get the data type. This one dey store date values, and as you don see am, we get our date format: the year, month, and day. The timestamp, this one sef we dey use am for recording time. So the year, month, date, hours, minutes, and seconds. So it is similar to the date format. And then blob, we dey use this one store binary large objects, and we fit also use am store large data. So now some of the core concepts for relational database be this. E dey very important make we understand them because e go familiarize us with many of the things wey we go dey see for inside MySQL. So we don come to the end of this tutorial. See you in the next tutorial.